Yes, student, let's start the class. Good morning, everyone. Am I audible to you?
Sorry.
Yes, sir.
Yes,
Okay,
sir.
okay, fine. Thank you. Is my screen is visible to you?
Yes, sir.
Okay, fine. Is there any doubt about the regarding the last classes? Okay, fine. So after the last numerical, this is our next topic, which is stresses in beams due to unsymmetric bending. Okay. So all of you, please go through this. What is this written here? So for this unsymmetric bending, how we need to solve and what is the procedure? We will go one by one. First of all, we will derive a derivation. After the derivation, we will solve a numerical. Okay, it's a very simple one. So all of you, please go through this. So here it is. What it is saying that in case of unsymmetrical section, when load, say any section along x, bending moment are developed above the neutral axis, as a result of which stress are also developed. To calculate the stress bending formula, there is a formula. I think all of you got this formula in earlier also in strength of materials or some like that. M by I equal F by Y. So our second point is while the bending moment about the other axis is say 0, but in case of unsymmetrical section or symmetrical section which are inclined on which a external load is acting about the section is not perpendicular to the symmetrical axis, and as a result of which two different component of external load is developed, which gives rise to two different bending moment. Means if a force is applied in any unsymmetrical section or any symmetrical section which are inclined at any angle, say theta. So even if we resolve that force into two component, I think all of you know that for force resolution, if we resolve that force about the x-axis and y-axis, we will get two component of that force. So it is saying only about that. Okay, as you see here, there is a load is acting at angle theta. If we resolve along the x-axis and y-axis, we will get two components. Say here P is the force applied at the angle theta. If we resolve it along the x-axis, then we can get P cos theta, and along the y-axis we will get P sin theta. Okay, this is simple thing. So how we will derive this? Okay, so for the derivation part, all of you please listen carefully. We are considering any arbitrary point. Okay, arbitrary section here. Here you can see this is a section, any arbitrary section we are taking along that x and y axis. Also we have drawn the principal axis. I think all of you now it is clear. There is two axes, one is Cartesian and another is principal. Okay, so if you remember that x and y is the principal axis and u and v are the x and y is the Cartesian axis and u and v is the principal axis. Okay, so here you see we are considering any arbitrary area. Here is the axis x and y, u and v is the principal axis, and theta is making the angle about u and x, which we have already calculated in the earlier numericals and derivation. How we need to calculate this theta. the angle between the principal and Cartesian axis. Okay, so here you see there is a load acting along the y-axis, okay, through the centroid. Here it is showing in this little bit right side, because if I draw along the y-axis you will not able to understand, but it is along the y-axis through the centroid G. Okay, so for this load, if we resolve this load along the x-axis, see here component of W, what is the along the UU axis and along the VV axis. We will go to, because here you see this theta angle is here along the V axis. So if we resolve this W, you will get along the y axis it is W sin theta, and along the theta you will get W cos theta. Okay. So this, due to this two load, there must be two bending moment also developed. So what is this bending moment component along the y u axis and v axis? Okay. So along the u-axis, our bending moment component is m cos theta, and along the v-axis, it is m sin theta. Let's go through the steps. Okay, this is very simple derivation. This is also not important, but solving the numerical, we just need this. Okay. So as I have already said that bending moment for a particular bending moment is bending stress is given by m by I equal f by y, and this f is nothing but it is stress. So I think all of you know we can replace by it sigma. Sigma is denoted, stress is denoted by this sigma. So how, after resolution, sigma is given by m by I into y. This is the simple formula. I think all of you got this. So in case for two bending moment along with the original, there will be extra bending stress. So all of you need to remember this formula. Okay, this formula we are going to use. So you just remember this formula. For this derivation, this formula we require. This sigma is given by m cos theta by I u into v plus m sin theta by I v into v. Okay, this formula, you all of you remember this, because this is going to be used while we solve the numerical. Just give me a second. Okay, all of you please read this question. We're going to solve this. Okay, let's go through this numerical. And this formula, I think all of you please remember, this is u. Okay, not v. Okay, last part. This is m cos theta by I u into v plus m sin theta by I v into u. Okay, this is not v, this is u. This is v. Okay, here it is wrong. Please correct it. This is u. Okay. So here, see one question. A wooden beam of cross section, the cross section is given 100 mm into 150 mm, used as shown in figure. This is the figure. This is the wooden block A, B, C, D. Okay, to support a sloping Mangalore tile roof. It has an effective span of 4 meter and carries a UTL of 3 kilonewton per meter, acting vertically downward. determine the maximum stress developed in the beam. So what we need to do, as per this question, first of all we need to draw a beam. Okay, here you see we have drawn a beam of span 4 mm. As per the question, it is given 3 kilonewton per meter. UDL is acting vertically downward, so this is 3 kilonewton per meter. So this is our section. This is 100 mm dimension. This is 150 mm. Okay, so for this section, this is a rectangular type of section, so we can easily say the centroid is at half of that section. So here you see below, for your understanding, it is written G is at 50 and 75, means half of 100 and half of 150. Okay, so what we need to do, we need to determine the maximum stress developed at this section. Okay, so all of you see this, how we need to solve this. All these things are given. So how maximum bending moment, I think all of you know, for a UDL, how we need to find out the bending moment. It is simply WL square by 8. So just put the values, everything is given, W given, L given. So after putting this, we are getting the value as 6 kilonewton per 6 kilonewton meter bending moment. So here you see, since in the beam maximum stresses occurs either compression or tensile at the top and bottom surface, our required point for the calculation will be A, B, C, D. Here you see this figure. Okay, so we can't say without solving this where is the bending moment is maximum, where is its minimum. Okay, it may be compression or it may be tension. So for that, for finding out this, we need to find out at every point like A, B, C, D. So how we are going to solve this? You see, first we need to find out this momentum inertia about u axis and v axis. For rectangular section, all of you know what is the formula. It is bd cubed by 12. Simple. So just along the u axis, when you select, it is 100 into 150. When you select along the v axis, it will be just the opposite. Okay, our b will be d and d will be b. Okay, here it is not written a unit. All of you please don't forget to write the unit. Okay, what will be the unit? Can anyone respond? Please speak, okay? Because I am sharing my screen, so I'm not able to see your messages.
Millimeters
Anyone,
per force.
any
millimeters
one of you,
for
please.
Millimeters per force.
Okay, fine, thank you. It's mm to the power 4 because our all dimensions are given in mm, and mm into mm cube, mm to the power 4. Okay, just remember this. So next, what we need to find out for this finding out this formula, what we already say, we need to find out two component. It is m cos theta and m sin theta. So our m we know. Okay, it is 6 theta. Theta is given, yes, it is given as 30 degree. Okay, so just simply put m cos theta. I think all of you know 6 into cos 30 degrees how much, all of you know. Similarly sin 30 degree, so just putting this value, find out these two value, m cos theta and sin m sin theta. Okay, so after this, what we need to do, we need to find out the stress at every points, like at A, at B, at C, at D, for this section. Okay, for this section, A, B, C, D. Okay, at every point we need to find out the stresses. So this formula we are going to use. Okay, this is the formula which I have already said. Okay, here I have used A because we are finding at A. So MUU by IEU into VA. Here we have written A. Here we have written A. Here we have written A because we are finding at point A. It is not compulsory. If you not write, it's also fine. But for every point, we are using some different notation. Okay. So just simply put the all this value and find out what is the stress at that point. Okay, and what is this, and what is this, v and u. This you need to find out by drawing the x and y axis similarly as we did earlier. Okay, along the section you need to draw the axis, and you have to check at which coordinate your A point is, your B point is, your C point is, your D point is. According to that, you need to find out the coordinate of that point. Okay, P and E. P, this is U. Okay, I think it is not clearly written here. The formula is MUU by IUU into VA plus MVV by IVV into UA. Okay, so it is simple. You just see where is your A point. If you draw the x and y axis along this, okay, see if you draw these two section here, okay, this is your x suppose, and this is your y. Are you able to see this? I think this section is small. I will draw a bigger one. If I draw a section like this, okay, this is your A point. So all of you see, are you able to see this? Please, anyone please respond.
Sir,
Is it visible to you, this section what I have drawn?
Yes, sir.
Okay, so all of you know this our dimension is given, this is 100, is it? So here this side also we know, in this side also this is 150. Okay, okay, I think all of you have understand for these things, I think. So see, so this dimension and this dimension is given 100 and this side 150. So our point, this is, if we consider this as x-axis and this is as y-axis, so from this I think all of you can easily say at which coordinate our A point is, which coordinate will be our B point, at which coordinate is our C point, and at which coordinate is our D point. So in this case, in which coordinate is our A point? Anyone please respond.
third coordinator, sir.
Yes, okay. And third coordinate, what is our sign?
Uh, I forgot, sir.
Ah, you forgot.
It's negative, I guess.
I guess you are guessing. As an engineering student, it is taught in your school trigonometry, sign
What?
convention in coordinate. So I think all of you should remember this. Okay, this is the basic thing you have studied in your school level mathematics. Okay, in which coordinate what is the sign? So in your first coordinate, in your second coordinate, in your third coordinate, in your fourth coordinate, what is the sign?
In first
I think
coordinate,
in the
both positive.
where?
So first one both positive, then second
Okay,
one positive and negative, third one both negative,
okay,
then fourth one negative and positive.
okay. Third one is both negative, is it?
Yes, sir.
Okay, so now you see here. What is the value? Here. Are you able to see this
Yes,
and
sir.
see this?
Maybe.
Is both are negative, is it?
Yes, sir.
Okay, and what how it is finding out 75 and 50? It is simple, because our dimension, it is this side it is 100 and this side it is 150 given. So half of this, because from the center we need this distance. Okay, So it is exactly at the center, that x and y axis. So you can easily say, from if we go to the in the x axis it is 50, in the y axis it is 75. Simple like that. Okay. So just writing this value and put all those values, MUU, MVV, IUU, IVV, everything we have already calculated. Just you need to put these things, put these values, and you will easily come to find out this. Okay. Similarly, again you need to find out for that point B. Same way, just put all this value, find out the coordinate at which coordinate that B point is. As per that, you use the sign. Okay. Similarly for point C, for D. Okay. Just repeat the steps. It's very simple. Only confusion is only you have to learn how you need to find out that coordinate, okay, for each section. And I think all of you know at which point it will be our compression, at which point with our tension. Can anyone say me as per the section? If we consider a section, say this section A, B, C, D, if we applied a load from the top, which portion will be at compression and which portion will be at tension? Can anyone say me? I think you see here, you see, I have written one word, this, tensile. After finding out this also will be, you need to write here. Again, here also you need to write. Here also you need to write. It will be tension or compression. So how can you say that? Which point will be in tension and which point will be in compression? Can anyone say?
A B will be in tension and C
Okay.
will be.
Yeah, for this beam, Michael, if we apply the load like here, from here, how it will bend?
And the top fiber will be in compression and the bottom fiber will be in tension.
I think, excuse me, it will come something like this. If we, sorry, okay, I'm not able to drawing correctly. I think please try to follow. Okay, I think if we put a load here, our beam will look like something like this. Is it? It will bend like this. Is it?
Yes, sir.
Yes, sir.
Okay. So what you said, Michael, at which portion it will be compression, at which portion it will be tension?
The top part.
Okay,
CD
top part will be
compression.
okay compression, and the below bottom part will be as tension. Okay, so we can easily say as per the loading system and for the beam which part will be in compression and which part will be in tension. That's why you see here it is written tensile. Here you need to write again tensile because this is our B point. This is our B point. Okay. So similarly, this is at C. This is our C. It is at the top, and it is our D. Okay. So this is our A. I think it's okay. You will understand. This A, B, C, D. So as per this, at which position these points are, as per that you need to write this tensile and compression. Okay. All of you, please try to solve this numerical. This is a very simple numerical. I think you will easily can solve. Just remember the formula. The simple formula you need to remember. And as per the coordinate system, you need to find out this coordinate at which point, as per the point where it is belong, as per the Cartesian axis. You need to find out the coordinate. Just put these values, all these values, and you will easily find out. Okay. So, is there any doubt anyone have?
So I have a doubt.
Okay.
So at stress at point B, there is written the PB as 150. So it will be
No, no,
150
no,
or
no,
70.
no, no, no. This is not 150. This is wrong. Okay.
I think
This is
so.
half of that. Half of that. It's wrong here.
Yeah, yeah.
It is
Yes,
wrong.
sir.
It is wrong. Don't follow. Simply follow that. Okay. Just follow whatever I have explained as per the formula, as per the procedure you go, you will easily solve. I will also give you the figure of sorry, I will give you the pics of this, okay, from the book also. Don't worry about that. You just compare both the notes and try to solve by yourself, okay? Okay, all of you please give your attendance in the text box, okay? All of you please give your attendance in the chat box, and if you have any doubt, you can ask me, okay? All of you just simply write your last digits. It's okay. No need to write a complete. And all of you please go through the notes once. If you have feel any doubt, you can ask me, okay? Till then, I am noting your attendance, okay?
Okay, sir.
If possible, all of you please turn on your video. I want to see you all. It's been long. We are not able to see each other. Is there anyone left to give you attendance? Okay, if not, it's okay. We will join after 10 to 15 minutes, okay?
Okay, sir.
For the next class, we will join, and I've seen there are some less students. Why? Are they not informed about the class?
So I think this is the user.
Mm-hmm.
So this is the user of the number of students who normally come to college as well.
Just pass the information in your groups. Join. They want to join or not is this is their own choice. They
Okay,
are
sir.
losing their attendance on all these things. Okay then. Thank you. We will join after 10 to 15 minutes later. Okay. Thank you all.
Thank you, sir.